Given that a is constant and the integral of 3 root x plus a dx between the limits of 1 and 4 is equal to 2a squared, show that there are exactly two possible values for a. So the first thing we would want to do is rewrite 3 root x plus a in a form that's a bit easier to integrate. So the square root of anything can also be written as it to the power of a half. It means the exact same thing, it's just another way we can write it. But writing things in terms of powers makes them a lot easier to integrate. So if we write 3 root x as 3x to the power of a half, it becomes a lot easier for us to do our calculation. So now we have it in this form, we can integrate what's inside the brackets, so 3x to the power of a half plus a. And the way we integrate is if we add 1 to the power, so 1 plus a half is 3 over 2, and then we do 3 divided by 3 over 2, which is 2. We're left with 2x, and then we keep the power of 3 over 2. And we do the exact same for the a, but we can imagine a as ax to the power of 0, because anything to the power of 0 is 1. So if we imagine it as ax to the power of 0, adding 1 to 0 gives us ax to the power of 1, which is simply ax, and dividing a by 1 leaves us with a still. Dividing anything by 1 keeps the number the same. So a integrates to simply ax. And then we keep, because this is still between the limits of 4 and 1. So the next thing we do is we substitute in, for x, we substitute in 4 and 1. So we always do the larger limit first, which here is 4. So we do 2 bracket 4 to the power of 3 over 2 plus a bracket 4. And then this is take away, the exact same thing, but we replace x with 1 instead of 4. And now, if we put some of these into our calculators, 2 multiplied by 4 to the power of 3 over 2 is 16. Then this is plus 4a minus 2 minus a. Remember that because this minus is on the outside of these square brackets, the a also becomes negative. This can trip people up sometimes. So now we're left with, if we simplify this a bit further, 14 plus 3a. Now in the question, we're told that this is equal to 2a squared. So if we write this out, we now will end up with an equation that we can solve. So 14 plus 3a equals 2a squared. And therefore, if we take away 3a and 14 from both sides, 2a squared minus 3a minus 14 is equal to 0. So the way we can now solve this is either using the quadratic formula, or we can do it by inspection, by looking at it. And this is one of the questions where it becomes easier actually to just do it by looking at it. So the way we'd solve it is we need to look for two numbers that multiply to make minus 28, because this is what the 2 and the minus 14 multiply to make. So we need to look for two numbers that multiply to make minus 14 and add to make minus 3. And it just so happens that there are two numbers and they are whole numbers, and they are minus 7 and 4. So the way we write it is we split up the minus 3 in the middle to the 4a and the minus 7a. Because this is the exact same thing, 4a minus 7a is minus 3a, but we're splitting it up into a way we can factorise. So if we factorise the first half of this, the 2a squared plus 4a, 2a goes into both of these terms, so we can write it as 2a bracket a plus 2. And similarly for the last two terms, minus 7 is a factor of both. So then inside the bracket, we get the exact same thing as the other side, which should always happen, a plus 2. And this is still all equal to 0. So now we keep the a plus 2, and in the other bracket, we use the things outside of each bracket, so 2a minus 7 as our second bracket. And this is still equal to 0. And now the way that we then solve this is we say for a plus 2 equals 0, so therefore a is equal to minus 2. And for this bracket, if 2a minus 7 is equal to 0, if we add 7 to both sides and divide through by 2, a is equal to 7 over 2. And these are our two values of a that we're asked for in the question. Now, in this question, to get our marks, there are 5 marks available. So, first of all, we get a mark for method and answer for simply writing that 3x to the power of a half plus a integrates to 2x to the power of 3 over 2 plus ax. So this is 2 marks, one for the method and one for actually getting the right numbers. Our next method mark comes from using these limits and then setting them equal to 2a squared. So this is now 3 marks in total. And then we get a method mark for solving a quadratic at all. And our last mark comes from getting the right answer, so getting that a is equal to minus 2 and 7 over 2. And this is all 5 marks for this question.